Hi guys, today we're going to look at geometric probability. I know you've looked at it a couple days with the Explore Learning or the Gizmos, but I also just wanted to take time for us to work through some examples together. There's no homework today. You will have homework tomorrow over it, and then on Friday and Monday I want you to design your own game board, and you will do some theoretical and geometric or experimental probability with it as well. So today no homework, tomorrow a little bit, and then Friday and Monday you'll be completing a project. Okay, so just a quick reminder about probability. We have theoretical probability is what should happen, and in geometric probability it's the area of what we're looking at, the specific shape, over the total area of your game board or your picture. Okay, and then experimental is what actually happens. So if you're throwing darts at it, it's how many times you get the success over the number of trials. Okay, so we will be looking at that in the next few days. So let's just jump in. I wanted us to go through some examples. Okay, and I'm going to call these game boards, although they don't have to be that. Okay, but so looking at number one, we want to find the probability of hitting the shaded area. Okay, so let's look a little bit closer at that. Now this one seems maybe weird because it has no numbers associated with it, but what we do see is that these are all equal sized. Okay, and so if we want to take the shaded area, how many of them do we have? Okay, we have 4 shaded areas, right, out of the total number of triangles we have. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4 out of the 8, which is a half, or 0.5 is perfectly fine, or 50%. Okay, so there's a 50% chance of hitting that shaded area. In a game scenario, this would be called a fair game because you have 50% chance of getting it and 50% chance of not getting it. Okay, so this is as likely to happen as it's not. So this would be a fair game. Okay, so let's look at number 2. And here we notice that, again, we don't have any numbers, but we have 4 equal segments, right? 1, 2, 3, 4. And how many of those are shaded? There's 3. Out of how many are there? 4. So this doesn't reduce anymore, but this is our geometric probability of hitting the shaded region. Okay, so 0.75 or 75% would be what we call that. So again, the theoretical probability, if this was my game board and I threw a dart out of it, 3 out of 4 times I should hit that shaded area. Okay. Now, is that going to happen every time I throw 4 darts? No, that's where experimental probability comes in. Okay. Is this a fair game? It's definitely fair for the contestant. It actually favors them, right? It's over 50%. So Carnival is not likely to have this one, right? Because they don't want you to win. But in this scenario, it is more likely to win than not. Okay, so let's look at some that are not as simple in the sense that they have different size shapes. Okay, so here again we do want to find the probability of hitting the shaded area, and you kind of have to think of a plan. What do we have? Okay, so we want to know, how do I find this shaded area? Okay, now we've done that with composite shapes, right? This is a big rectangle minus the little rectangle, right? So again, if you can think of it as like a gray rectangle in the back, right? And that's a 15 by 9 rectangle. And then someone's come in and put a white rectangle on top of it. That's 3 by 9, right? So it's covering it up. And so to get the gray rectangle, we would have to take the gray rectangle minus the white rectangle, and that would leave what is showing. Okay. Now, with the probability part, we have to put that gray area over the total. Okay. And so that's the area of the big one in this case, right? That gray one that got covered up. Okay. So the area of the big is 9 times 15. okay, minus the white that got on top of it, so 9 times 3, all over the 9 times 15. Okay, and so then we go ahead and simplify that. 9 times 15 is 135, I believe. Okay, so we have 135 minus 27 over 135, which is 108 over 135. And again, I would go ahead and write it as a decimal or a percent so that you don't have to worry about leaving your fraction unreduced. But if you want to, you're welcome to leave it as a fraction. Just make sure it is reduced. Those both reduced by 9 and maybe even further. Okay, so now if this was a game, would this be fair or would you want to play it? Possibly, because it's saying 80 times out of 100 you should hit it, or 8 out of 10 times. So it's not a bad thing at all to have. Okay, so let's look at this next one. So what two shapes do you see here? Okay, we have the bottom shape is a rectangle, and then someone came over and put a white shape on top of it, right? The circle. So again, to hit these corners is what we're asking, like what's the probability of hitting those corners? Okay, so what we have to do is find that gray area. And to find that gray area, again, we would take the area of the square, because that's what we started with. But then someone either came and cut this out or they laid something on top of it. So that's the area of the circle that we have to subtract. Okay, so that gives us our gray area, right, which is what we've wanted before. But now we want to look at it as a probability. So we have to compare it to the total shape, which is our square. Okay, so then it's just the filling in the blank part. So what's the area of a square? Well, to find the area of a square, it's the base times the base, or 10 squared. And then how do we find the area of a circle? Okay, well, it's pi r squared. Okay, so what's our radius here? Okay, well, 10 is our diameter, right? So we only want half of that, so it's 5. So 5 squared pi over our total area, which is the square again. Okay. So 10 squared is 100. And if we take 5 squared pi, or 25 pi, I am going to round that. I'm going to make 3.14 be my pi. So 100 minus 78.5 divided by 100. And so we get 0.215 or 21.5%. So if this was offered at a carnival, would you be interested in playing this game? Maybe not as much as the game before, right? Because it's only a 22% chance of winning. Okay, does that make sense? Okay, if that makes sense, why don't you try number 6 and then come back and check it with me? It's similar, but they just flip-flop the shapes. Okay, so you can pause the video, try it, and then come back. This time our circle's in the back, so we want to take the circle minus the square and compare it to the circle, because that is our overall shape. So again, what is our radius here? Well, 8 is a diameter, so from just the center out is 4. So we're going to have pi times 4 squared minus, okay, and that goes on the bottom too. Okay, well, do we know how to find the length of the square? Because we don't have it right now, do we? Okay, so we're going to have to do a little bit of thinking back. Okay, we can do this by using our 45, 45, 90 triangle. Or if we forget that, I will remind you that we can use the Pythagorean theorem. This is a square, otherwise it wouldn't be inscribed in a circle. Okay, so we have x squared plus x squared equals 8 squared. So 2x squared equals 64. X squared equals 32. So x is equal to the square root of 32, which we're going to call that 5.7. Okay. So we have pi r squared, which is pi times 4 squared, minus 5.7 squared. Okay, so if we go ahead and put that in our calculator, I guess that was kind of a bad one to have you try by yourself, but maybe you did. Okay, so 16 times 3.14 minus 5.7 squared, and then if we divide it by 16 times 3.14, should get about 0.35 or 35%. Be careful here, you're going to want parentheses around that. Okay, if you don't get that, that may be what happened. So is this a fair game? No, it's better than the game that we just did, but it's not a very fair game either. Okay. And how about this one? What shape do we have? We can look at it as a trapezoid, we can look at it as triangles and a rectangle. Okay. What I see is a trapezoid with a rectangle placed on top of it. Okay, so I'm going to take, to get the gray part, that's my trapezoid, but I take away my rectangle. And the whole game board is a trapezoid. Can you do triangles? The answer is yes, if you can figure out the measurements, but I prefer a trapezoid in this case. Okay, so I have 20 for that. So area of a trapezoid is the 20 plus the 14, because that's my two bases, times the height is 12. And I divide that by 2, minus the length and width of my rectangle, which my rectangle is 14 by 12. All over this trapezoid again, which maybe it would have been easier if I'd found it first. Okay. So let's see if you can see that now. So my trapezoid, I'll go ahead and find that. That's 20 plus 14 times 12, divide by 2, okay, which is 204. And then the 14 times 12 is 168. And then I divide it by 204. So let's see what that gives us. And that's about 0.176 or 17.6%. Okay. So again, it's finding out that big shape minus the little shape over the total area. Okay, so a couple more that I'd like us to, or at least one more. Two more. Okay. So let's look at number 7 in this case. So I will put in a empty or a blank worksheet here in case you want to work these out as you go. I should have told you that at the beginning, but you can always go back and do that. Okay, so here I have two circles and I have a rectangle. So I'm going to have the area of the rectangle, because that's my overall shape, minus the two circles that came in on top. And then I divide by my rectangle. So the area of my rectangle is 3 times 4. Okay, so that's great. We know we have two circles, okay? And they need to be pi r squared. So what's our radius? Okay, so they're kind of be tricky here. Now I know 4 across, okay, and I have two identical shapes, so that means I get cut in half. So this is 2 and this is 2. And those are diameters though. So what's a radius? Okay, well a radius is just 1. So that's how I figure that out. So I get 12 minus, and so this is 1 squared times pi, which is 3.14 times 2, so minus 6.28. So 12 minus 6.28 divided by 12 is about 0.48 or 48%. So almost fair, right? Favors the house a little bit, but 48%. Okay, so use your diameters to get your radius as you need to. Okay. And the last thing I'd like us to look at is closer to a traditional dartboard, right? It's got a ring inside of a ring at least. Okay. And so notice here we started with the white shape and then we put either a ring on top or we put a gray circle and then put another white circle, however you want to look at that. But so I'm going to say the area of the big white circle. Okay. Okay. And then if I take away what? So if I take the area of the big white circle, sorry, if I start with the big white circle, and then I take the area of the gray circle, okay, well that's good, except now I have this little hole here, so I'm going to add back in the area of the little white circle. Okay. Now, are there other ways to do it? Probably, but that's what I see. I see the big white circle in the back, and then I took away this. Okay. And then I have that. So is that what I want to do? Okay, so I am having a brain blurb, so just a second. Okay, scratch that, I apologize. Okay, let's get back on the right track. Let's just find the gray, right? That's all we wanted. So we want to do the area of the gray and then take away the little one, okay, because that'll give us this ring. That's right. So the area of the little white circle. Okay, so again, I'm trying to find that gray area. I don't care about this big white one in a minute. So I just need the gray, and then I'm going to take away this one. Now, when I look at the total, we want this big white circle, right? Okay. So area of the big white circle. There we go. So to find the gray, all we do is take the gray minus the little circle. Okay, that's how we get this ring. Okay. But then we do, our whole game board is this big white one. Okay. So that's what we need. I apologize for that. Okay. So the area of the gray. So we have pi r squared minus pi r squared all over pi r squared. So now we just have to go make sure we have all the right radii in there. Okay. So the gray circle. So the area of the gray circle would go from the center to here. Okay. And so this part is 2, but then we also have the little white one. So from the center to the gray outside is 3. Okay. And then minus the little circle. So the little circle has a radius of 1. Okay. And then the big circle has, here's 1, here's 2, and then here's another 2, is what that said right there. So 2 plus 2 is 4, plus 1 is 5. Okay. So we get 9 pi minus pi over 25 pi. And again, you can put that all in decimal form. So 9 times 3.14 minus 3.14 divided by 25 times 3.14. We get about 0.32 or 32%. You could also see here that 8 pi over 25 pi, the pi's go out, so you get 8/25, which is 32%. Okay, so that's how we do that. Tomorrow I will have a few problems for you to try, and again, on Friday and Monday you will make your own game board. Okay, so we will talk to you later. Let me know if you have questions, please.